right, guys, so we come back to 5-6, finding another way of finding the roots and zeros. Now we've done it with graphing. We have also done it with factoring. We just learned completing the square, which is probably the least of ones I'd use. The quadratic formula is a good rule to use. And again, using the coefficients a, which is in front of the x squared, b, which is in front of the x, and c, which is the number all by itself, we can put them into this little formula right here, and that will give us the roots. And it'll even solve it for if we have complex roots. And that's really the benefit, because when you graph it, if you have imaginary zeros, the roots, the calculator won't give it to you. So this is kind of a method you'd have to use in order to find that. So it's good to know this. And by the way, I'm not a big tattoo person, but if I ever get one, it's going to be this on my shoulder, I think. We'll put the quadratic formula. I think that'll be pretty cool. So let's try it out. So remember the quadratic formula. You don't have to memorize it. Just go back to it. We're going to take, again, remember it's the opposite of b plus or minus the square root of b squared minus 4ac all over 2. So here's what we got. The b is right here. It's -4. So we're going to do the opposite of that. That's 4 plus or minus the square root of, well, b squared. Remember, that's always going to be positive when you square something, 16. All right, and then we're going to go minus 4 times a, which is 2, times c, which is 1. All right, and then we're going to go all over, let's see, yeah, I have that wrong, all over 2a, isn't it? Yeah, so again, we'll have 2a down here, so that's going to be 2 times 2, which is 4 down here. All right, so when we simplify 4 plus or minus, well, 16 minus 4 times 2, that's going to be the square root of 8 all over 4. And we do want to simplify that if we can. We're going to go 4 plus or minus. Now remember, the square root of 8 is 4 times 2. Square root of 4 is 2, so that's going to be 2 root 2 all over 4. And we can take a 2 out of all those, so it's really going to turn into 2 plus or minus the square root of 2 all over 2. If we divide all of those, so we have to divide this, this, and that all by 2, and we get that simplified version. That's what we get, both of those. Wow. Okay. Yeah, those can be kind of complex, kind of tough to see as we go, but that's how you use the quadratic formula. All right, let's try another one here. Let's use this one. All right, so again, we use the opposite of b plus or minus the square root of b squared, which is 9, minus 4 times a times c. Remember, it's a -7 all over 2a. All right, let's see what we get here. Well, we get -3 plus or minus, well, let's see, what do we get? Let's see, that's 28. This is going to be the square root of 37 all over 2. Can't really simplify the 37, so I'm okay with you just leaving it like that. There you go. If you can simplify the radical, I would, but this one you can't. So there you go. Wow, okay, yeah. Doesn't work out that great. Now, one of the big things we have with this quadratic formula is this part right here. It's called the discriminant. That b squared minus 4ac part. That will tell you how many solutions that you're going to get. And we've talked about this before, is that you can have 2 solutions. So if that discriminant, that under the radical, if that b squared minus 4ac, if it's positive number, you're going to have 2. If it's equal to 0, that's where you have 1. And if it's a negative number, that's where we have the imaginary number. So there's no real numbers. There's just 2 imaginaries is what we have there. So by doing that, we should be able to check that out. All right, so here's some examples with that. If we were to use the quadratic formula, let's put it, get everything over to one side first. All right, got to make sure it's always set equal to 0. That's the key there. So when we do the discriminant part, if we do the b squared, remember that's the b squared minus 4ac part, that's under the radical. So if we square the 12, that's 144 minus 4 times a times c. Well, if we run that in, that actually is 0, isn't it? So in this case, there's 1 solution. Okay, so if that discriminant part, that's this part right here, if that equals 0, there's 1 solution. All right, let's try it this time with the same kind of thing over here. X squared minus 12x plus 40 equals 0. So if I do the discriminant, again, we get 144. That's the b squared minus 4ac part. All right, so minus 4, a is 1, c in this case is 40. Well, it's 144 minus 160, that's -16. So in this case, there's no real solutions. No solutions, there'd be 2 imaginary solutions is what we would have there. All right, and then here's yet another example. Same kind of thing. We're using the same numbers here. X squared minus 12x plus 30. All right, so b squared 144 minus 4 times a times c. Well, that's going to be 24. So since that's positive, there's actually two solutions. So just by checking that discriminant, again, that's underneath the radical. That's that b squared minus 4ac part. All right, remember, if it's positive, there's two solutions. If it's zero, it's one solution. And if it's negative, you're going to have no solutions, and they're just two imaginary solutions, I guess. So look at all the different things that we've done. Solving for quadratic formulas, finding those roots. We have all sorts of tools in the toolbox. Graphing, great, as good a method as any that you have. The only downfall of that is that if you have imaginary zeros, you can't find them with the graphing part. Factoring is great, so if you can spot check, you're good at those, but some quadratics are not very good or easy to factor. Square roots using the completing the square method, yeah, that's probably the least of my favorite methods, but it's good down the road when we start looking at things called conic sections like ellipses and hyperbolas. It's going to be important to use that method on there too. So it's nice to have some familiarity with that. And then, of course, we have our quadratic formula that works, and it's probably the most universal of all of them that works for everything. So lots of different things to use, and hopefully we get some practice with that, whether you have two solutions, one solution, or no reals but two imaginaries, we can find those. So we have lots of good things that we've learned in the first 6 sections.